So we'll look at bipolar very briefly to start with, and we'll look at it more detail in the practical application in another session. So the bipolar is the simplest mode, and essentially the machine is generating a current which comes down one wire, and then the current's going to be retrieved through a second wire back to the machine. So we will have two wires in this machine, and we'll look at this more in another session, but these leads go in front of the machine, and then at the end of this there's a connector into which we put typically a bipolar forcep here. So we have the current coming down one wire to the tip of forcep on one side, and then the current's going to go across to the tip of the other forcep and back up the other wire and back to the machine. So when I hold a piece of tissue in the tips, the current is allowed to pass through the tips, between the tips across the tissue to produce the biological effect. And so that is bipolar, and it's almost exclusively used in the coagulation mode. And by the coagulation mode, we mean that the current produced is a sine wave, but there's a pause, and then further sine waves, and these are a relative high voltage. So this produces a change in the tissue that produces protein coagulation, and then produces a control of bleeding. So that in essence is bipolar. And I suspect that's how most veterinarians use the machine most often. It's very simple. You can use it, you can set it up at any time during surgery because the current is simply going from tip to tip. The other use for this device, which is much more adaptable, is monopolar. So I'm going to disconnect this here for a moment. It's going to tell me that I've disconnected. You can hear a beeping noise in the background telling me that the machine is unhappy. So with monopolar, we have, first we need to have a patient plate. So we're going to have a conductive plate which is going to underneath the patient. Patient is going to be on top of this, and this is what brings the current back to the machine. To take the current to the patient, we have a cable, single cable this time, with an instrument on the end. Here's our patient. And now we have a circuit that is from the machine down the cable through an instrument tip, through the tissue of the patient, to the patient return plate or the conductor plate, and back to the machine. So it's a slightly more complex setup, and when we talk about the practical application, you see the importance that we have connectivity between the patient and the patient plate or the return plate here. And typically for this, we use something like I often call this the pencil. So this is a monopolar instrument that's supplied with the machine, and it's a fairly standard fitting. And you'll see on this, we have two buttons. We have yellow, which you now know is always cutting, and we have blue, which is coagulation. So during surgery I can choose to either use yellow, which will divide the tissue, or I can use blue, which will provide coagulation. And that yellow, coming back to the machine controls, I could choose to either use a pure cut yellow or a blended cut yellow. Now the machine, when it's in the cutting mode, produces a sine wave that is continuous, and in the blended mode it uses both of these at the same time, which I'm not going to try and draw. So we see that we have a tissue action which includes both a cutting and coagulation at the same time. So that's the basis of what the machine can provide for us. And now we should look at the power settings, and then when we look at the practical application, we can look at what that actually means in a real patient. So we see on the face of the machine here, we have these dials which control the power, or the level as it's put here. And level is probably a better word, because this is a nominal power. In other words, you'll remember perhaps from high school that the current that flows through a material is dependent both on the voltage and the resistance. So we can adjust the voltage, but what we can't adjust is the resistance of the tissue. The resistance of the tissue is innate to the tissue in question. So in other words, we're not controlling the current, which is the measure of power, directly. What we're doing is adjusting the voltage, and then the patient features will affect the resistance and therefore affect the current flow. That is all a slightly complicated way of saying that if you think that every time 40, perhaps on this, is going to have the same effect on the tissues that you're dealing with, then you are mistaken, because this is not the same as the power, because the power delivered is going to depend on the tissues. So we know, for example, that muscle has a low resistance, and therefore we can have a lower number on here, and we will have a higher power, a higher quantity of energy delivered to the patient. Whereas fat, for example, has a very high resistance, and therefore you would need a much higher level to deliver the same amount of energy to the fat. And so although we could offer some guidance to the numbers you would choose to start with when you're using your electrosurgery device, you will discover that you do need to make some adjustment yourself, and we'll look at the adjustment in another session. And the same is true for coagulation. So these are nominal. They will not be the same for every patient, and in fact they're not directly transferable between machines. Certainly not between different brands and different models of the machine. This is a nominal number, not an absolute wattage, as it were. So I think that brings us to the end of a very concise version of the face of the machine. Some of the simple concepts, in particular to emphasize the difference between bipolar, typically delivered with a forceps, where the current is simply between the tips, and monopolar, typically delivered with a pencil, where typically we have a choice between yellow for cutting, blue for coagulation. But remember, with the monopolar, this is the mode when we have to have the patient plate underneath the patient, because the current is going to come from the machine to the tip of the handpiece, through the patient, back to the return plate, and back to the machine. So that's the key difference. I hope that's been a useful start for you, and in another segment we're going to look at the practical application.